Imagine a world more real than real, a place where every sensation is heightened. You can touch it, smell it, taste it, and every experience feels incredibly vivid. Your heart races in your chest, your emotions surge, you feel truly alive. But what if this world, our world, was just lines of code, a sophisticated digital construct? What if we were merely data points in a vast cosmic computer program existing within a digital framework? This is the mind-bending proposition of the simulation hypothesis, a theory that challenges our very understanding of existence. It suggests that our universe isn't real in the way we think, but a hyper-realistic simulation crafted by a far more advanced intelligence, possibly beyond our comprehension. The idea might sound like something straight out of a science fiction movie, but many physicists and philosophers take it seriously, considering its profound implications. Why? Because when we look at the universe through the lens of mathematics and information theory, intriguing possibilities emerge, suggesting a deeper underlying structure. The very fabric of our reality seems to be woven from the same threads that make up computer programs, hinting at a digital origin. The simulation hypothesis isn't about proving that we live in a matrix-like world with red pills and leather trench coats. It's about exploring the boundaries of our understanding, pushing the limits of what we know. It's about asking the biggest, most audacious questions about the nature of reality itself and what it means to exist. And in doing so, it forces us to confront the limits of our own perception, challenging us to see beyond the surface. The universe, at its core, speaks the language of mathematics. From the orbits of planets to the behavior of subatomic particles, everything seems to follow precise mathematical laws. But what if these laws aren't just descriptions of reality, but the very code that underpins it? Think of it like this. A computer program uses lines of code to create a virtual world. Similarly, perhaps the universe uses mathematical equations as its building blocks, dictating how everything interacts and evolves. This is where information theory comes in. This field explores how information is stored, processed, and transmitted. Intriguingly, some physicists believe that information itself might be the most fundamental aspect of reality. Just as a digital image is made up of pixels, our universe could be composed of tiny bits of information. If this is true, then the simulation hypothesis becomes even more compelling. It suggests that the same principles that govern our computers might also govern the cosmos. The simulation hypothesis raises a profound question. If our reality is so convincing that it's indistinguishable from a real one, does it even matter if it's simulated? This question challenges our understanding of existence and what it means to be real. After all, we experience the world through our senses, emotions, and thoughts. These experiences shape our reality, making it rich and meaningful. Whether those experiences are generated by a biological brain or a sophisticated computer program might be irrelevant to our lived reality. The essence of our experiences remains unchanged. Some argue that the distinction is crucial. They believe that understanding the true nature of our existence could have profound implications. If we're living in a simulation, then the rules of the game could be different than we think. This could mean that our understanding of physics, time, and even morality might be fundamentally flawed. There might be glitches in the matrix, hidden backdoors, or even the possibility of breaking free. These anomalies could offer clues about the true nature of our reality. Others contend that such speculation is pointless. They argue that without concrete evidence, it's just an intellectual exercise. Without a way to definitively prove or disprove the simulation, it remains firmly in the realm of philosophical thought experiment. This doesn't diminish its value, though. Even if we can't escape the simulation or even confirm its existence, the very act of contemplating it can be enlightening. It encourages us to think deeply about our perceptions and beliefs. It forces us to question our assumptions about the nature of reality, consciousness, and our place in the grand scheme of things. This introspection can lead to a greater understanding of ourselves and the universe. No discussion of simulated realities would be complete without mentioning The Matrix. This groundbreaking film franchise took the simulation hypothesis from the realm of academic debate to mainstream pop culture. The iconic red pill, blue pill dilemma, the mind-bending action sequences, and the philosophical questions it raised captivated audiences worldwide. The Matrix tapped into a deep-seated human fear, the possibility that everything we perceive as real is an illusion. But it also offered a glimmer of hope, the idea that even within a simulated world, free will and rebellion are possible. The film's impact on popular culture is undeniable. It sparked countless conversations about the nature of reality, technology's potential to deceive us, and the very meaning of existence. While The Matrix took creative liberties with the simulation hypothesis, it also helped to popularize the idea and make it more accessible to a wider audience. In doing so, it sparked a cultural conversation that continues to this day. Section 5. Echoes of the Ancients, Cycles and Simulations. The idea of a simulated universe might seem like a product of our modern, tech-obsessed age, but surprisingly, it has echoes in ancient philosophies. For centuries, cultures around the world have pondered the cyclical nature of time and the possibility that our universe is just one iteration in an endless series of creations and destructions. In Hinduism, for example, the concept of Maya suggests that the physical world is an illusion, a veil obscuring the true nature of reality. Similarly, ancient Greek philosophers like Plato proposed that our senses deceive us and that true reality exists in a realm of perfect, unchanging forms. While these ancient beliefs might not map directly onto the modern simulation hypothesis, they share a common thread: the idea that our perceived reality might not be the whole story. They suggest that there could be layers of existence beyond our comprehension, realms where the rules of our universe no longer apply. Section 6. Layers of reality beyond our dimension. Our brains evolved to perceive a three-dimensional world plus time. This perception shapes our understanding of reality, but it might be just a small piece of a much larger puzzle. But what if the universe is far more complex than that? What if there are hidden layers and dimensions that we can't even begin to fathom? String theory, a branch of theoretical physics, suggests that there could be as many as 11 dimensions, most of which are curled up and hidden from our view. These dimensions could be incredibly small, existing at scales beyond our current technological capabilities to detect. If these extra dimensions exist, they could hold the key to understanding the nature of reality itself. They might reveal new laws of physics, or even new forms of matter and energy. Imagine our universe as a flat sheet of paper. This analogy helps us visualize how limited our perception might be. We, as three-dimensional beings, can only perceive and interact with things on that sheet. Our senses and instruments are confined to this plane of existence. But what if there were other sheets, other universes, existing parallel to our own? These parallel universes could be just as real as ours, yet completely inaccessible to us. This is the mind-boggling concept of the multiverse. It suggests that our universe is just one of many, each with its own unique properties and laws of physics. Some physicists speculate that these parallel universes could be connected, perhaps even interacting with each other in ways we can't yet comprehend. These interactions could have profound implications for our understanding of reality. If so, our universe might not be a self-contained system, but part of a much larger, more intricate cosmic tapestry. This interconnectedness could mean that events in one universe might influence another. And if other universes exist, who's to say that some of them aren't simulated? The idea of a simulated universe opens up even more questions about the nature of existence and reality. Section 7. The Consciousness Conundrum. Real or programmed? Perhaps the most perplexing question raised by the simulation hypothesis is this: what about consciousness? If we are living in a simulation, does that mean our thoughts, emotions, and experiences are also simulated? Or is there something more, something that transcends the digital realm? Some argue that consciousness is an emergent property of complex systems. In other words, it arises naturally from the intricate interactions of neurons in our brains, or perhaps from the lines of code in a sufficiently advanced computer program. Others believe that consciousness is fundamental, a basic property of the universe like space and time. If consciousness is indeed fundamental, then it might be possible for it to exist independently of any physical substrate, whether biological or digital. This raises the tantalizing possibility that even if our bodies are virtual, our consciousness might be very real. Section 8. Conclusion. a reality beyond our grasp? The simulation hypothesis, despite its mind-bending implications, can't be definitively proven or disproven with our current understanding of the universe. It remains a tantalizing thought experiment, a philosophical rabbit hole that forces us to confront the limits of our knowledge and the very nature of reality itself. Whether we are living in a simulation or not, the very act of contemplating such possibilities can be a source of wonder and intellectual stimulation. It reminds us that the universe is far stranger and more complex than we can imagine, and that there will always be mysteries beyond our grasp. So, the next time you look up at the stars, consider this: are you seeing the real deal or just a high-resolution projection? The answer might be beyond our reach, but the journey of exploration is what makes the cosmos so endlessly fascinating. Section 9, Bibliography, Green, B, 2010. The Elegant Universe, W. Norton and Company, Hawking, S, 2010. The Grand Design, Bantam Books, Tegmark, M, 2014. Our Mathematical Universe, Alfred A. Knopf.